Hi, this class is to talk about hypothesis testing when you don't know the population standard deviation. Okay, this is chapter 9, and what we are doing, we are testing if the population mean we find in a sample, a point estimator of a sample is higher or smaller or different than a hypothesized number. And we're going to be using sample data, confidence level, and z-scores, all let's say concepts that you learned before. The process is very similar to what we did with the z-score, but now we have a t-score. The t-score is used because now we don't have the population standard deviation, and we have to use the sample standard deviation to come up with the variability in the sample. So what we're doing is we're comparing the value we hypothesize in the hypothesis with the value found in a sample. And this is done by this numerator here. This is comparing the sample mean with the hypothesized mean. Are they really different? Are they the same? If they're the same, the resulting number would be 0, and the t-score would be 0, which would be in the center of the distribution, and then we would fail to reject the null hypothesis and accept that they're the same. Okay? So this is what we are doing. So the t-score is very similar to the z-score and standardize this difference between the sample mean and the hypothesis. Let's take a look at one example here. A business travel magazine wants to classify airports according to the rating the travelers give to these airports. A rating scale with a low score of 0 and a high score of 10 will be used, and airports with a rating greater than 7 will be designated as superior service airports. So this is very important information to come up with our hypothesis. So what we have is that the null assumes that all ratings are smaller than 7. So we always doubt that airports are good until we have enough evidence that they are. The evidence is that the ratings are higher than 7. So this is the null and alternative hypothesis. A sample of 60 business travelers, so I have a sample size of 60, were surveyed at the London Heathrow Airport, which provide a sample mean rating. So I have a sample mean rating of 7.2 and a sample standard deviation. Oh, what happened? What happened? Okay, let's, okay, it is here. I'm sorry. I'm so sorry. I was trying to find my notes. So I have a sample mean rate of 7.2, and this is a critical information here, sample standard deviation. Sample standard deviation doesn't say population standard deviation. You have to pay attention to that. It doesn't say population standard deviation. It says sample. Okay, so I have a sample standard deviation of 1.052. Okay, and because of that, I know that I have to use a t. I have to compute the t-score. Okay, so let's compute what is the t-score in this case. Let's compute the t-score. The t-score is 7.2 minus 7 divided by 1.052 divided by the square root of 60. Okay, so my t-score in this case is 0.2 divided by, let's use Excel to compute that. So let me clean this. So 1.052 divided by the square root, square root of 60. That's 0.13. So it's 0.2 divided by 0.13. Okay, so the t-score is equal to 0.2 divided by 0.13. So the t-score is 1.47. 1.47. Okay, so what is the t-score? Where is the t-score in the t-distribution? Right? What is the t-score in the t-distribution? If we come here, then we have a t-distribution. This t-distribution has some degrees of freedom. Degrees of freedom is 1 minus, is the sample size minus 1, which is 59. Okay, so depending on how this distribution is, we're gonna have like a different position for 1.47, but 1.47 is positive. Okay, so in this side, but it's not too big number. Okay, so we have to test and see if this t-score is really a big number to result in a second unknown distribution like I showed you in the other classes. Okay, so this is what we are doing basically. So the steps to test the hypothesis are very similar to the steps I showed you in the previous videos. So you have the critical value approach. Here the steps very similar. You have an additional step here, which is compute the degrees of freedom. In step 3, in step 4 is specify the level of significance. If lower tail, use as it is. If upper tail, do 1 minus the alpha. If it's 2 tail, do alpha divided by 2 and do these two things. So you learned how to do that before, okay? And then after you get the alpha, you find the t critical associated with the level of significance you got in step 3. You use this function here, this formula in Excel. Okay, I'm gonna show you in another video how to do everything in Excel. And then you collect the sample data and compute the test, the value of the test statistic. This is the test statistic. This is the test statistic. Test statistic. Okay, so you do that. You compare with the t-critical. Remember, it's a very similar procedure to the one I showed you before. And then if the t resulting t statistic, this number here, resulting t statistic, is within the rejection region, remember the rejection region, then we reject the null hypothesis. This is what step 7 is saying. Compare the test statistic. If it is smaller than t-critical, reject. If it is higher than t-critical, reject. If it's 2 tail and t is smaller or higher, then you reject. So here are the rules to reject or fail to reject the null hypothesis. Okay. Here are the rules again, one more time. And then we have the p-value approach, again, very similar to the p-value approach I showed you in the previous slide. So develop the null alternative hypothesis, determine if it's lower, upper, 2 tail, compute the degrees of freedom, specify the level of significance, collect the sample data, and compute the test statistic, and then find the probability of the test statistic, this one. What's the probability of this test statistic? If it's lower tail, that's the reason you have to know if it's lower, upper, 2 tail. If it is lower tail, use this formula. Let me show you. Let's compute the probability of this test statistic using this formula. So the first question is, which tail we are talking about in this problem? Remember, because the alternative hypothesis says that has to be higher, has to be upper tail. It's higher. Okay, so if it is upper tail, I'm gonna use this formula here. Let me show you how to use this formula in Excel. So this is the test statistic. So the formula is 1 minus equal 1 minus t dist. Okay, equal 1 minus t dist, and then that's the t statistic. The degrees of freedom, how many degrees of freedom we have in the problem. This is the reason I compute the degrees of freedom, 59. So 59, comma, cumulative is 1, close parenthesis. That's the probability, 0.07. Remember, 0.07 is not a strong evidence. So in this case, we got the p-value. Compare the p-value you found in this step with the level of significance. We don't have a level of significance because I'm not using the full problem. But let's say the level of significance is 0.01, the typical 0.01. So if I come here, I have 0.07. 0.01 is my level of significance. Let's go back here. Compare. If the p-value is smaller than the level of significance, reject null hypothesis. So this is level of significance. If this p-value, this is p-value. So if p-value is smaller, I reject the null. Well, p-value is not smaller than 0.07, is not smaller than 0.01, so I fail to reject the null hypothesis. I accept the null hypothesis. Okay, so this is the p-value approach. Okay, so I'm gonna stop here and show you how to solve this full problem in Excel and also this other problem in Excel, and that's it.